And as we start chapter 3, we are looking at acute angle geometry. Girls? Okay. So an acute triangle is a triangle that has what? What would be an acute triangle here?
90 degrees.
No.
What?
Nice try. Sorry, acute triangles, not 90 degrees. No, it doesn't have a 90 degree. That's
I
a
said 90 degrees or less.
well, 90 degrees or less. It's not 90 degrees, though. It can't be 90 degrees. So that's a right triangle.
Less than 90
But
degrees.
if we just take the or less part, then that's exactly right, Hannah. Very good. So acute triangles have all three angles are less than 90. Well, I heard 90 or less. Isn't that what you said? 90 or less?
You said 90.
So I think you said 90 or less, but that's okay. Maybe that's what you meant. Okay, guys. I mean, everybody just quiet down, please. Okay. So a triangle that has a 90 degree angle is a right triangle, and we've explored in grade 10. We've taken a look at sine, cos, tan. That's right triangle geometry. In Foundations of Math 20 here now, in chapter 3, we're taking a look at acute triangles. So we have triangles that don't have a 90 degrees. So you can't just use sine equals opposite over hypotenuse in a triangle that's not a right triangle. So this is right here a picture of a rock formation, and you see the little outline of an acute triangle here. Okay? So as we kind of take a look at this is kind of what I want to focus on, this little activity here. If you take a look at this triangle, okay, so ABC is an acute triangle. All the angles are less than 90. Okay? And it's been broken up a certain way into two right triangles. So in order to figure out how we're going to find out some relationship between the sides of an acute triangle, we need to first split it into two right triangles to kind of start with what we know, right? So we need to start with what we know about right triangles. So I've clipped this over into our notes here. So if you could just jot that down real quick. Just a little sketch. So just any kind of acute triangle ABC, and then drop an altitude height line down from the top vertex there. And the question we're going to be answering is this. What are the two equivalent expressions for H? What are the two equivalent expressions for H? Okay. So we know that in this diagram here, that's a right angle, and this is a right angle, right? And so I can use the SOHCAHTOA. Remember that? Remember SOHCAHTOA? Okay, SOHCAHTOA. That helps us remember how the trig functions can be written out. So sine of a particular angle equals the opposite side length divided by the hypotenuse length, right? So how can we use the trig ratios of these two now right triangles to write an expression for H? How is H related to B, for example? So what trig ratio can I set up? What trig equation here? Here's a hint with sine. Okay? So sine of B equals what? What does sine of B equal? H over C. Very good. It's because H is the opposite side to B, and C is this hypotenuse. Okay? Okay, is there another expression that I can have H in as well involving another angle? Let's say maybe C here. Not A, because we've got the two triangles set up where, see, this A is right here, right? So what is the opposite side? This is the opposite side, but now we don't have a right triangle if we use A. You see that? So we're not going to use A. It's a good guess. But we're going to use C over here because this is part of the second right triangle. See that? Okay. So how is H related to C? So what equation can I make with the angle C and H in it? Sine of C equals H over B. Okay, you guys agree with that? Okay, good. I'm glad you didn't do like maybe tangent, because tangent would be opposite over adjacent, and actually it looks like maybe this is the adjacent side, but actually A is the whole side. So tangent wouldn't work, and neither would cosine, because it would involve, because we don't know this length right here. So yeah, sine is exactly right. Okay. So we write that out, and sine of C equals H over B. Okay. So let's solve for H in each of these equations. Let me bring this one down here, and we'll bring this one down here. So if I were to isolate H in this one, what would H be equal to? Yeah, C times sine of B, because I just multiplied both sides by C, right? So H equals C sine B. We're getting somewhere here. Just trust me here. Just be patient. Trust me. All right. What about this one? H equals what over here? H equals B times sine C. Did everyone see that? All right. So let's just stop right here and we'll just back up for a second. And why did we introduce H in here anyways? Well, just remember that ABC, this triangle right here, is a non-right triangle. It's an acute triangle, and the trig functions don't work just the same way on acute triangles. They have to be applied to right triangles only. So if we drop this altitude down here, this height down here, then now I have two right triangles, and now I can use those trig functions. Okay, so that's what we're doing. And the H isn't going to stay there. Why is the H going to be gone here in a second? Does anyone see a property that we've been using in chapter 1 and 2 here? Does anyone see how I can merge these two equations?
Because they both equal H.
Exactly. So for those of you that didn't hear that, because this equals H and this also equals H, because they both equal the same thing, these two actually equal each other. That's very good. So we're getting really close here now. So B sine C actually is the same as C sine B, because they both equal the height. So what we're doing is we're developing a relationship now that doesn't have anything to do with H or the right triangles that we've actually put in there, right? So now we've kind of gotten rid of the right triangle part of it. And what's interesting is this is called the sine law. When we do one more thing here, so we're going to divide both sides by sine C and both sides by sine B. And when we do that, those are gone, and that sine B comes over here. So we end up with B over sine B. And these are gone, and that sine C is actually divided over here too. So that's over C, or C over sine C. So again, this is from the same triangle that we started off with, this ABC triangle, and now we don't have any H in there. So let me see if I can just copy that, bring it down here. All right. So the H is effectively gone, and what this relationship is, what this means is that if I know this side and I know this angle, okay, and a neat thing also that you'll see in the textbooks is if you have big B for an angle, the opposite side is always little b. Okay, so that's how that works. Big C, the opposite side is always little c. Big A, the opposite side is little a. Okay, so that's something you're going to want to pay attention to. That always happens. That's something you can predict. So if I know this and if I know this, all I need to know is one other either angle or side, and I can figure out what's missing. So if I have this angle, I can figure out what C is. Okay, so we're kind of using the trig function sine, but it's not sine equals opposite over hypotenuse, right? So we're still using the trig function sine. Anyways, just to complete this, just to finish this off, okay, if I drew this altitude somewhere else, like for example, if I did it here, from here all the way down to make a perpendicular right here, well, then we can connect A and B, right? So then it would be A over sine A equals B over sine B. And of course, we could do a third one right here and do the same thing. And so what you end up getting is all three of them equal to each other again by the transitive property. So look at this. B sine B is equal to this one, and B sine B is also equal to this one. So that means that these are equal to each other as well. So what we've just developed here is the sine law, and the sine law can be written like this. So let's write it out here. Okay, sine law. So for any acute triangle, A, that is the length of any of one side, divided by the sine of its associated angle, is going to be the same ratio as one of the other sides divided by the sine of its associated angle, and so on. This ratio would be the same as well. Okay? So next section talks about, next section further develops the sine law. This is just an intro. 3.1 is an intro. So really, we're merging 3.1 and 3.2 together a little bit here today. But so what I'm going to do is I'm going to give you examples from 3.1 and 3.2. And so like I say, we're going to be doing 3.1 and 3.2 over the next couple days. So because they really spill into each other, I'm going to kind of keep going and give you some examples from both. All right. So let's do an example here. Let's say I have a triangle that is an acute triangle, and I have an angle here of 52 degrees. Right there. This side length is, well, let's say 8.5 centimeters. And I have another length here of 7.2 centimeters. So let's call this angle A, this angle B, and this angle C. All right. So I'm going to ask you here to find angle C. So if you look at this, you're only given one angle, so you can't use 180 minus, two of the angles to get the third one because you're only given one. So you're going to have to use this sine law, okay, or this relationship. And so let's just set it up. We have a side length. Let's start with one of those that were given, 8.5, divided by, and so what goes underneath it is the sine of the angle that is opposite of it, right? That's associated with, so sine of 52. And we're going to be able to set up a really simple equation here because I can fill in values here as well. So I've got 7.2, and I would complete this relationship by saying this is divided by the sine of C. Okay? Now, you learned this in grade 10 at least, maybe before in grade 9, but I'm going to ask you just to take 30 seconds and manipulate this equation, solve for C. Okay? See if you can do it. I'll do it as well here, and I'll freeze the screen, so you can do it on your own, I'll do it, and then I'll unfreeze the screen and show you the answer in a few seconds. So go ahead and give this a try. Find C. I've got it kind of started for you. All right, so hopefully you've all had a chance to give this a try. Some questions that I've had, some observations that I've seen just from walking around the classroom here. Okay, this is what I gave you, okay? And we're trying to isolate for C, okay? So, again, you're trying to get this out of the denominator first of all, and you're trying to get C all by itself. So how do you get this out of the denominator? You multiply both sides by sine C. Okay? So that brings sine C up to the numerator on this side, and it gets rid of it down here. Then you want to get rid of this to the other side, so you multiply both sides by sine of 52. And that's what brings it up over here. Then you want to isolate sine c and 8.5, that they're multiplied right now. You want to get rid of this, so you divide it. Okay. Now, I didn't show all of those little steps, because at this point you probably should know how to do that. If this is an issue for you, okay, you'll have to come talk to me, and I'll give you some extra practice or something. But in order to manipulate the equation, you should have been able to get sine c by itself. The shortcut of all of that, the shortcut is, in a simple proportion like this, this bottom one can go up to the top and be multiplied by this. This bottom can go up to the top on the other side and be multiplied by this. And of course, this one can also go to the bottom of the other side. So these switch places, these can switch places. That's the shortcut for all of that. So if you look at that, that's kind of what I did, right? Just to get to this step. This goes up here, that goes down there. And this goes up there. So that's kind of what it all turns out to be when you do your multiplication of both sides and dividing both sides and stuff. Okay? So to get sine c by itself. Now, when you get sine c by itself, right here, you should get an answer about this, yeah?
Will we have to show that much work?
Yes. Will you have to show this much work? Yes.
Can we just yeah. Can we just
You need to show your process. I won't expect you to show all of those steps in between that I started to show, but this would be full marks on an exam. Yes. If you went straight from this to this bottom and you did all of that moving around in your head and all the calculations on your calculator and you didn't communicate your process, yes, you would be missing some marks. Yeah. Okay. So again, the reason why I'm pushing this, right, is because I don't want you to make mistakes. And if you do make one little mistake on the calculator punch and you get the completely wrong answer and you don't show me any work, then I don't know how close you are, to knowing what you're doing. I really don't. So you have to communicate some way. So that's why I need you to show your work. Okay?
Do we have to do that on the multiple choice question?
If it's a multiple choice question, I don't need you to require you to show all your work. But short answer questions and stuff like that, and you should be practicing your homework. So yes. And again, I know some of you look at this and you say, I can do all this in my head and get the right answer. This is an easy problem. The questions will get harder. And the process is all you're going to be relying on, okay? And many of you are going to be moving into calculus too, where you're going to do a question that's going to be 2 or 3 pages long. If you can't do all that in your head. You have to be doing your process, okay? Not many questions are going to be 3 pages long. But the point is that showing this work takes about literally 7 seconds to write it down. And then it's less chance you're going to make a mistake. Now, just the final thing, I know there's some hands, just the final thing here. To get c by itself now, do you remember how to do that? Yeah, what you got to do there is you have to use the second function sine, right? So once you get this number, to peel away that sine function from the c, you got to do sine to the negative 1, okay? So sine to the negative 1 of both sides. That's how you get rid of the sine. The inverse sine really is what it is. Okay? Inverse sine. That's what undoes it. So 41.9 or so, that's what you should get for the answer. How did everybody do with that? Did you get that answer, or do you now understand how you get that answer? Yeah? Okay. Okay. So that's one example here. Let's do one more. So this example, Toby uses chains attached to hooks on the ceiling and a winch to lift engines at his father's garage. The chains, the winch, and the ceiling are arranged as shown in the diagram here. Toby solved the triangle using the sine law to determine the angle that each chain makes with the ceiling to the nearest degree. He claims that theta, and this is a Greek letter, theta, equals 40 degrees. And this one, do you guys know what this Greek letter is? That's a Greek letter as well. A, it looks like an A. Yeah, it is.
Omega.
What is, no, not omega. Close. Alpha. Right. Alpha is the first letter in the alphabet. Omega is the last letter in the Greek alphabet. the alpha, the omega.
Oh, so is that like
Right?
omega, like the thing in the dog? No, like, isn't it like some like vitamins?
Maybe.
Protein
Yeah, I don't
or
know.
something like that?
Okay, so alpha is 54. Now, basically, they're asking you to prove if he's correct. Okay, so if it's not correct, then you have to make the adjustments. Okay, so again, use the sine law, right? So the sine law involves A over sine A equals B over sine B equals C over sine C. Now, I don't want to throw you off or anything, but if you took the inverse of all of these, that relationship would hold true too. So really, what I'm saying is that this is also a corollary, really, of the sine law. Oops, sine C over C. So you could look at it that way too. That's okay too. Doesn't matter. All right, so we have 86 and 2.8. Those are related. Hey, boys in the back, pay attention. Okay. 2.8 divided by sine of what? Josh? Okay, 2.8 divided by the sine of its associated angle, which is right here. You can't read that. Okay, it is a bit small. You might need to move forward then at some point. Oh, bring your glasses. That'd be good. Yeah, that'd be good too. Yeah, if you got glasses, bring them if you're going to sit in the very back. Okay. All right, so sine, let me help you, Josh. This is 86 right here, okay? It's 86. So 2.8 divided by sine of 86. Okay. Now, what does that equal? Do we have another pair of angles at all? Or, an angle side pair? Or... Okay. Oh, actually, thank you for saying that. What did you say? Sine alpha over... Okay, everyone watch this. Okay? Sine alpha over 2.2. Does that okay? Does that look right? You want to make that adjustment? Okay, so what are we going to do here? Right. Okay, you're on the right track, although 2.2 is not opposite of alpha either. But that's okay. You can't read that either. Okay. Sorry, it is a bit small. It is in your textbook as well, actually, boys in the back. Yeah, and your textbooks are closed. Okay, you can open them. Anyways, page 121. Okay, so if we want to use alpha, if we want to find alpha first, that's totally great. Let's use the side that's associated with alpha. So that's 1.9 over sine alpha. Can I do that again? What? Draw alpha? Yeah, it's kind of like a fish. Yeah, that's alpha. Whatever. You can draw all different ways.
Alpha and omega. That's
Yeah, you just get that now?
I don't know.
Alpha and omega. Alpha is the beginning. Hey, you know another neat thing actually about the alphabet, guys? Guys, you know another neat thing about the alphabet? This is a side information. Do you know how when you're a little kid, your teacher maybe said, we're going to learn your ABCs? Or your mom said, you're going to learn your ABCs? Okay, so think about the word alphabet. The alphabet is the ABCs, right? Alpha-bet. The first two letters in the Greek alphabet are alpha, beta. So it's like your alpha, betas, alphabet. Okay. Blow your mind there? Okay.
So alpha's the first letter and omega's the last letter?
Yes.
Oh.
Yes. Okay. Okay. Guys, settle down, please. Please. All right. So if we're going to solve for alpha, we need to get the alpha function here. We need to get that all by itself, positive, in the numerator. That's the rules for isolating. So this goes up to, girls, zip it. Multiply both sides by sine of theta. Or alpha, sorry. Sine of alpha times 2.8. I'm going to show you every step of the work here now. Okay, this is what we have. Just so you see what's going on. See that? Multiply both sides by sine of alpha, it comes up there. And it's gone down there. So now I'm going to multiply both sides by sine of 86. And it looks like this. So we're getting close. Alpha is in the numerator, but it's not quite by itself yet. Divide by 2.8, both sides. Then you have sine of alpha all by itself. Okay? So that's the whole process there. Again, what you could do from this step, you could go straight to this step. I'm fine with that. Sine of alpha goes up there. Sine of 86 goes up there. 2.8 goes down there. Okay? All right. Let's quickly finish this. So you could go straight to your calculator here and you could do this. You could go second function sine 1.9 times sine of 86 divided by 2.8. I think your calculator should be able to handle all that at once if you want. 42.6. You guys get that? So what did he say? He said alpha was 54. Alpha is, we said 42.6. Okay. And then you would do the same thing for theta here, for this theta. You could use the original pairing, 2.8 over sine of 86 equals 2.2 over sine of theta. So use the same pairing if you want. So 2.8 over sine of 86 equals is that 2.2 over sine of theta. Okay? So sine of theta then will equal over here 2.2 times sine of 86 divided by 2.8. So I get 51.6 degrees here. And again, once again, the question was asked, can't you just do 180 minus your first angle? And of course the answer to that is yes, you can, but if you did something wrong in the first stage, then your second answer will be wrong as well because you used that error. So if you do it independently, then you have a better chance of discovering an error or not using that first error. What we can do though is check 86 plus 42.6 plus 51.6 should equal what? 180. Now that looks like 180.2, right? So if we haven't rounded, we've rounded here and we've rounded here. So if we rounded both of them up, we might be in trouble. Okay, so that's approximately 180, and it just would depend on our rounding of our decimals. So, okay, questions? Any questions? No? Okay. You think you're ready for your assignment? Okay. Okay, please, while I get your assignment ready, please look at the in summary on this page here, page 124.
I'm happy.